So I've not shared, I think, yesterday's recording. So first I'll do that. Mhm.
Okay.
Yes, I'm there. Just a minute, sir.
Huh?
Yeah, just a minute.
Okay.
There. Okay, we'll start. Oh, all done. Okay, so yesterday we have started with conditional probability, a step higher in the probability. So today we are going to see independence, just complete conditional probability and independence. Are you there, Zaid? Yeah, you are
Yeah.
there. Yeah. So yesterday we have seen the concept of conditional probability.
Mm-hmm.
Conditional probability. So we have seen the formula yesterday. So what was the formula? A given B. What does A given B means? Probability of B is happened. B is happened
Mm-hmm.
and A is to be done. Remember this.
Yeah.
Which is
Yeah.
written afterwards. It is happened and A is to be done. So it is given by, you need to remember the formula. It
Mm-hmm.
is very probability of A intersection B upon probability of B, or it can also be generally write it as, while seeing the two-way table, as number of element in A intersection B. This is number of elements, this one, upon number of elements in B. Okay. Or you can write the formula also as B given A,
Yeah.
means here what it is, probability that A is happened and B is to be completed, and B is to be completed. So what will be the formula, by the way? A intersection B, it remains the same upon probability of A, or it can be written as number of element in A intersection B upon number of element in A. That's it. So one thing I need to make clear here is that changing the alphabets in intersection doesn't changes things. Huh? Whether you write A intersection B or B intersection A, it will be the same. Just wordings are different. Remember this. In intersection, just wordings are, means I'm talking that what is the common between A and B, and I'm telling elsewise in the opposite sense what is common between B and A. It means the same. Okay. Why will be the probability be the same? Because number of elements in A intersection B will be the same in B intersection A. It will never happen that in any
Mm-hmm.
case it cannot possible that they are different. Okay, so that's conditional probability, means dependent on the condition when the things are fulfilled uh, or a task is taken out depending on the condition, then it is known as conditional probability. Okay. Yesterday, we had seen this. Yes, yesterday, right? This Instagram and Facebook was the
Yeah,
last
we did.
example, I think. Yeah. So now
Yeah, we
yellow.
saw, we were past this.
Yeah. N and E. Okay. So this example this also we have seen. No, we'll
Yeah.
solve this. Okay. So Yellowstone National Park surveyed a random sample of 1526 winter visitors to the park. They asked each person whether he or she owned, rented, or had never used a snowmobile. Respondents were also asked whether they belong to an environmental organization. The two-way table summarizes the survey responses. So this is the survey responses. Suppose we randomly, so I'll take this on my board. Okay. So suppose we randomly select one of the survey respondents, define event E. E is such that environmental club member, and S is snow mobile owner, and N is never used. Okay. So find P. Find we have to find first of all N given E. Given E means E is completed. E is completed. So we need to find the probability of N intersection E upon probability of E, or you can tell it as number of element in N intersection E upon number of elements in E. Okay. So okay, E is completed means environmental club members. Club member. So where is environmental club member? Yes, see this is. So it is E, number of elements in E. Yes or no? This is E. So it will be
Mm-hmm.
305 in the denominator. First you fix the denominator, it's 305 because denominator is very important. Where is N intersection E? Means they are an intersection E means never used and environmental club owners. So never used and environmental club owners. It's 212. Yes or no? So it will be 212 upon 305. That's the probability in this case. So we'll interpret it in the form of this also, point wise also. 212 divided by 305. It's 0. Huh? It's it's 0.6950, 0.6950, which is around 69.50%. 69.50. Got that right?
69.5. Mm-hmm. Yeah.
Yeah, yes, is easy. Okay. So remember this, E was completed. So it was in the denominator. How I found E? First of all, write the denominator first and then think about the intersection point, because the denominator is very important in this case. You have seen that
Yeah.
it will not happen that n given E and probability of E given n is the same. It is 99% not the same. Huh? Remember this. So it is very important to
Yeah.
get the denominator. Yes, that's the thing. So given that chosen person is not a slow mobile user, so given that means same thing. Remember the wordings. How do we call this? How do we call this? N given E. How do we call this? Probability of N given E. Given E means E is completed. I write it here because it is very important. And students generally make mistake in the exam here only. Given E means E is completed first. E is
So,
completed
so it's in
first.
the denominator?
Yeah, means it is in the denominator. It is in denominator. Or you can say denominator, or it is the main condition. It is the main condition. That's the reason it is called as conditional probability. Condition, and n is to happen, and n is to be happen. Got that? That's
Mhm.
the thing. So it's very crucial
Yeah.
that you decide what has been given to you, means what condition has been fulfilled. So you can see here he is very clearly saying that given that the person chosen person is not a slow mobile user, so what it is given, I'll write it here. Probability that given means after the line, not snow mobile user, not a snow mobile user. Okay, not snow mobile user. Okay. So what's the probability that she or he is an environmental club member? So which probability we need to find is written before the forward slash. So she or he is an environmental club member. Environmental
Mm.
club member. Okay. So we'll write it in notation form also. Remember, write your answer as probability statement using correct symbols for the events. So we have to write. That's the reason I have told you we have to write in the form of event. So environmental club user we have written here. It is E. It is E given, and it's I think N. It's N. Yes. E given N. Okay. Never used. Na? Chosen person is not a snow mobile user. Oh, not a snow mobile user. Na? So this is a snow mobile user. It was not never used. So that's the reason I have written things different, means wrong here. Not a snow mobile user means snow mobile user. It has the symbol of S. So what will be the symbol of not a snow mobile user? Z, tell me, come on. Can you tell me the symbol of not a snow mobile user? It is very important. You should be able to tell it. Come on. If snow mobile users is represented by S, see here. Snow
Yes.
mobile user. User. So what will be the symbol of this one? Not a snow mobile user. Not
Uh,
a
NS.
snow mobile. NS?
Yeah.
Leave that NS. No NS. No NS. See, snow mobile user is positive, not a snow mobile user. You see here. For example, I am drawing this. This is the whole sample space, and this sample space I'll give it as U. Okay, for example, and this
Negative
is no
S?
mobile user. Negative S means complement of S. Complement. And how do we write a complement of S? Complement of S. We have seen. Remember, whenever negative word comes, you think first of the complement. As you have assigned, I've told you in that also case when we have seen a previous example where there were male and female. Remember this. I had told that time also. If I am giving A to male, I don't have to give a different what you will say symbol to female, but it is a complement. Why? Because after leaving the male, the thing that will be left will be females. Yes or no? So female will be always represented by a complement. If you give a new event, it will be wrong. It will be wrong. Are you getting that?
Yeah.
Yeah, so you can write it as SC, S raised to C, S dash, any symbol. Two symbols were given in our textbooks, Advanced Placement Statistics. So that's the reason you can use any symbol. So what will be the notion of this? E means it was ECM. ECM was I just ECM was environmental club member or not a snowmobile user was this one. Okay, so we need to see where not a snowmobile user is. So where is a not a snowmobile user? So what will be a not a snowmobile user? Can you tell me?
Never used.
Yeah, yeah, yeah. Never used. That she or he is an environmental club member, given that the chosen person is not a snowmobile owner. Not a snowmobile owner, user name owner. And it was a snowmobile owner. Yes, not a snowmobile owner. So where owner is not there, Zaid, it is very clear. See, this is the owner part. And when we are looking, this is the owner part. And when we want to look, he's not a owner. So both of them will be in consideration, yes or no? Rented and never used, yes or no,
Yeah.
Zaid? It's very important. These
Yeah.
things. Little
Yes.
things matter. So we need to plus both of them. So the addition will be 7 plus 4 is 11. One carry 7 plus 5 it's 12. One carry was 13 and one it's 11 12. 1 2 3 1. So see here what will be
Mm-hmm.
the answer by the way. So coming on to the this it was where we have written, yeah, so it will be number of elements in E intersection SC upon number of elements in SC. So we have removed number of elements in SC. It is 1 2 3 1 1 2 3 1. Remember what I'm doing here, Zaid. He has told not a snowmobile owner. So I don't want snowmobile owner, but there are two conditions which are left. That's the reason I've taken the summation of these two. Yes or no? So this becomes my condition
Mm-hmm.
that is fulfilled further. Now I need to look, find the probability that he or she is an environmental club member. So he or she means I am considering, I'll erase all the things here because we are in the recording. You can look it again later. So I don't have anything consideration with this. I have this table now, this whole, because the summation is the whole year, the summation is whole year, the summation is whole year. Now I need to look into
Mm-hmm.
what's the probability that he or she is an environmental club member. So environmental club member means the addition of these two, the addition of these two,
These two.
this one. So it will be 7 plus 2, it will be 9, and 7 plus 1, 8, and 2 as it is, so 289. So it will be 289. So that's the thing. I'll show you the answer. We'll calculate the answer in decimal numbers. 289 divided by 1213. So 1231, by the way, 1231. So the answer is 0.2347. That's around 23.47%. That's the thing. Got that, Zaid? How to
Mm-hmm.
go through it? It's very important. Okay. Now to the next
Yeah.
question. What I'll do? It's very tedious to go up further, so I'll copy the table once more. Okay. So okay. So here now on to the third question that we'll go. Is the chosen person more likely to not be an environmental club member if he or she has never used a snowmobile? Is a snowmobile owner or a snowmobile renter? Justify your answer. So first of all, you have to complete the upper question first. Write your answer as a probability statement. So you need to write the answer in the probability statement. How you will write the answer in the probability statement? So the probability statement will be here in the upper case. Here the percentage, or you can write the probability that ECM given NSMU means probability such that not a snow, given that he is not a snowmobile user, and the probability that he is a environmental club member is 23.47%. So this will be a probability statement that you need to write in your answer sheet when he or she has asked you the question in the exam. Okay. So now
Mhm.
going on to the next question, is the chosen person more likely to be an environmental club member if he or she has never used a snowmobile, is a snowmobile owner, or a snowmobile renter? So what you have to do in this question, you have to just justify. You need to find all the probabilities. Is the chosen person not likely to be an environmental club member if he or she has never used a mobile? So means when, for example, you need to find environmental club member given not never used. This one, this was the first probability that you have to compare. You have to just compare probability of environmental club member given that owner, okay, owner, yes, and
Mm-hmm.
probability that ECM, environmental club member, given that he was a renter. Okay, so you need to find all the three probabilities, and what he is asking is the chosen person more likely. If there are the whole persons standing in a, what you say, in a room, and I'm choosing a one person at random. So which person has the highest probability to be chosen? So what we need to do, we need to find all the three probabilities. So we'll do it here. We'll do it here. We'll find all the three probabilities. Then we can comment on the question that he has given, whether it will be which one has the highest probability. So what will be the, what you'll say, formula for this? E intersection n upon number of elements in n. Here it will be a number of elements in E intersection O upon number of elements in O. Number of elements in E intersection R upon number of elements in R. Okay, from this comparison only, means the fraction only, you'll get an idea which number and which probability is greater and which is smaller. Okay, you need not go into the decimal form in the exam if it is difficult to calculate. So n intersection E intersection m means environmental club user. No, first we need to this finalize this condition, never used. So it is 657. 657 upon E intersection N, never use an environmental club member, it's 212. So it's 212. Same. O means owner, so it's 295 upon E intersection O means owner as well as environmental club. So owner as well as it is 60. Okay. So now then the next is renter. So it is 574 upon both of them 77. So we'll see. Uh, we need to calculate the point because the denominators are not same all the way, so we can generally compare it. So what we'll do, 212 divided by 657, so it's around 32.67, 32.67%. Here in this case what it will be, 16 divided by 295, 16 divided by 295, it's 5%, by the way, 5.4%. Okay, and in the next case what it will be, 77 divided by 574, so it is around 13.41%. 13. Come on, Z, now it's your task to tell me the answer, that if is the chosen person more likely, which person has the more possibility to be chosen. Come on, tell me, Z. The answer is in front of you.
32.67.
Correct, correct. So give me the answer in statement why. So a person who is an a person who has never used a snowmobile owner is never used a snowmobile and is an environmental club member, has the highest probability to be get chosen from the whole slot of persons. You got that?
The one that's most likely is the
Correct.
environmental club member who has never used a snowmobile.
Yeah,
Yeah.
very good. Justify your answer because its probability is the highest. That's the justification.
Mm-hmm.
And the justification you have given in the form of calculations also. So the calculation is very important. Means if you have in mathematics, if you have done the calculations well and explainably right, then you don't need to give the justification more in the statement wise because it is not literature. It is mathematics. That's the thing.
Uh-huh.
Okay, so we have completed another this question, and it was very interesting, I think. So. The question now comes the concept of conditional probability and independence. Okay, first of all, we'll look into the general definition of independence, conditional probability, and independence. Conditional, as it is very easy, by the way, conditional probability and independence. Okay, so you have seen conditional probability. Okay, we'll just discuss what does independence means. Independence in this modern world, or you can say a liberal world, in the sense of Islamic view that it's a liberal world today. All in all the states and all the countries, all the Western world is talking about women's independence. Women's independence. So there is a general idea what does independence means. So can you tell me what does independence means? We generally talk about self-independent
Freedom.
things and all.
Something that's
Freedom,
limited, but that has its own thing,
yeah, that's
has
the thing.
its own
Own thing.
section.
Own section, own thing, freedom. Can I tell the thing which is not dependent on other thing, the things, or you can say if we are talking about a person, we can generally write it as if I'll cut this the if the thing are not dependent on other things, if the things are not dependent on other things, then that is known as independent. Or you can say if a person, in the sense of a person also will, right, then the thing, then that is known as independent. That is known as, that thing is independent. That thing is independent.
Independent.
Independent means some, if there is some person, okay, likewise we as a student, if we are if that, like was I was a student, I was dependent on my parents, that they used to pay my school and college, high school and college fees. They used to feed me 3 times a day. Why? Because Allah subhanahu wa ta'ala has put some dependency on them, of me. That's the reason I cannot tell that I was independent. Okay, today also I am not independent with my parents, because there are some or the other tasks that is that which I am dependent on them. Okay, we cannot be independent of our parents. We always need them in our life, whether they,
Mhm.
if they are alive or if they are not alive, we are dependent on them, because parents play a very vital and important role in our life. So we cannot be independent of our parents. But it can happen that in independent sense, that I am independent of some other person. Means I don't need any support. What you say, any emotional or mental or physical support of the other person, which I am, for suppose person one. So I can tell that I am independent of person one. Independent of
Mhm.
person one means what? I don't have any liability. He doesn't hold any liabilities of mine. Okay, so means I am not dependent on him. That's the meaning that I am independent of person one. That's the thing. Is it clear what does independence mean in general literature?
Mhm. Yeah.
So I am independent of person one. Now there's a, what you will say, fitna or
Yeah.
thing going into the world, that women are self independent. That's not the case. Allah subhanahu wa ta'ala has told us in the Quran that there are some laws that has to be followed by women. They can do their own business, they can do what they want, but Allah subhanahu wa ta'ala has given responsibilities of women onto her father first, and if she is married, then to her husband. You got that? That's the thing that Islam
Mhm.
teaches us. So Allah subhanahu wa ta'ala has made women very safe, very put them in a comfort zone, so that they don't need to rush in life. Okay, do more hard work. Okay, that's the thing. So coming on to our, back to our statistics topic. Okay, so independence, the thing is very clear. So now, what does in statistics independence means? What does independence in statistics means? What does independence in statistics mean? So what's the case? Okay. So means what? If A is a event, I'll give you one statement and then we'll see the example and the explanation of textbook also. If A is an event and B is also an event, B is also an event, and if we find probability of A given B, and it will be equal to, and it will be
Mhm.
probability of A, means what? Probability of A given B is equal to A. What does this mean? That condition of on B means we have taken. What does this mean? Probability A given B. that we have put condition B on A. Yes or no? Put
Mhm.
condition B on A. So what does this mean? That putting a condition of B on A is not changing the probability. Yes or no? A given B is same as
Mhm.
probability of A. Means what we can tell, that means A is independent of A. A is independent of B. A is independent of B. Means putting some
Mhm.
condition of B on A. That's the thing, na? We are putting condition B on A. So when we are putting condition B on A, it is not affecting the probability of A. It is not affecting the probability of A. You can see calculating it. We'll see calculating it. So that is the thing we say, that they are independent, or elsewise it can be given as B given A. What I have condition I have put on B, I have put the condition A. Okay, and it is same as B, means the condition of B,
Mhm.
condition of A on B, condition of A on B. This means, so means if it is not, if it is the same, if it is the same, then B is independent of A. B is independent of A. You
Mhm.
can write it in general form, that if A is not affecting B, if A is not affecting, conditionally affecting, you can say, if A is not conditionally affect, is not conditionally affecting B, conditionally affecting B, then B is independent, then B is independent. Okay, and same, and similarly, if B is not affecting A, if B is not conditionally affecting A, conditionally affecting A, then A is independent. Independent of B is independent of A, and A is independent of B. Independent of B. That's the case. Okay. And if both the condition is fulfilled, if both the conditions, if both the conditions are fulfilled, means what? I'll not write in the statement form. Fulfilled, fulfilled means A is independent of B, independent of B, and same as B is independent of A, B is independent of A, then we say both are both are independent events. Both are independent events of each other. Of each other. You got that, said what I need to say. Likewise, if probability of A given B is equals to C, probability of A means A is independent, and if probability B given A is equals to probability B means B is independent. Got that? Yes or no?
Mhm. Yeah.
If both this condition is fulfilled, we can say that A and B both are independent. Okay, now I have explained you the whole topic of independent event. By the way, we just need to read the things that he has given in the textbook. Come on. So just give me 2 minutes. Just I'll take a break and then continue. Okay, just 2 minutes.
Mhm. Okay.
Okay, so you are there. I'm back.
Yeah.
So conditional probability and independence. So suppose you toss a pair coin twice. Define A, first toss is a head, and B, second toss is a head. Means what? A is such that we need to record the notation that if then there is a first toss is a head and B is such that second toss is a head. So we know that probability of A is half and B is half.
No.
How I explain. So two coins are tossed. So sample space is HH, HT, TH, and TT.
Uh-huh. Yeah.
What is A?
Oh, okay.
First coin. First coin
Mm-hmm.
is head. Is head. Okay. So
Okay.
what will be come in head? So it will be HH. Here see first coin is head and same here HT. So what will be the probability of A? It will be half. Same as what is B? Second coin is head.
Mm-hmm.
Second coin is head. So you look into the sample space. Okay.
Yeah. Okay.
So what
Yeah.
it will be second coin is head. See here. This as well as this same. HH will come here also and TH. Okay. So what will be this probability? Practice calculating the probabilities of different events. What I'll do here in India, there is a textbook of probability and it has very much what you will say good questions, interesting questions. So I'll forward you that. So what you do, just practice that questions, finding the probabilities of the events. Okay. So both of them have probability half. Okay.
Mm-hmm.
So what's probability B given A? What's probability? We need to calculate probability B given A. So what will the probability B given A means that such that what is A first of all? On the first coin means on the first coin it is head. Okay. Probability of B
Mm-hmm.
given A. So B given A means what will be the probability? Just a minute. First we will write in wordings form. I'll write in okay, B intersection A upon probability of A. Correct? If we want to write in statement
Mm-hmm.
form, what it will be? Probability that B means head on second coin. I'll write neatly here. What does this mean? Probability B given A means probability second second coin head when given first coin head. Given first coin head means what? That we want head on the second coin such that first coin has head. Means which will be the sample space of this when you will see the intersection means it what will be means B intersection A upon probability of A. So what will be B intersection A
Mm-hmm.
means it should have head on the first coin as well as on the second coin. So what will be the sample space of it? HH only, yes or no?
Mm-hmm.
Upon the whole 4, correct? This will be the probability or not?
Mm-hmm.
That is equals to 1 by
Yeah.
4. And what will be the probability of A? 1 by 2. So it will be 1 by 4 upon 1 by 2.
Yeah. One
1
by
by
eight.
4. So it will be not 1 by 8, right? Not 1 by 8. So it is
Huh?
1 by 4. And when you want to turn this division into multiplication,
Oh no, it's
you
it's one half. It's one half. It's one
take the
half.
reciprocal. 2 ones are 2 twos are. So it's 1 half. Okay. That's the thing. That's conditional probability. So that's half. So what's P given A complement? You need to find it. You will do it as a homework. So it is also half. So in this case, probability of B given A equals to probability of P given A complement, which is equals to probability of B. Knowing the outcome of the first toss does not change the probability that the second toss is head. We say that A and B are independent events. Note this case. See what we'll calculate. Okay, come on. We'll calculate probability of what you'll say probability of B given A complement. So what will be probability B given A complement? B intersection A complement upon probability of A complement. And you know what is probability of A complement? I have told you probability of B intersection A complement upon What is probability of A complement? 1 minus probability of A. Yes or no? You remember this complement rule?
Mm-hmm.
Yeah.
Yeah,
So
I
it will
remember
be
it.
1 upon 1 minus half. So what will be B intersection A means first this condition should be fulfilled. Na? Means what?
Mm-hmm.
First there is head. There is no head. No head. We don't want a head. We don't want a head. Correct? So we don't want a head. So what comes into picture? What is left? We don't want a head on the first this. So HT TT. Correct? Then what is
Mm-hmm.
B? That we want head. So this gets cut on the second phase. So what we are left with? TH, correct? So what will the probability of this? 1 by 4. 1 is the this and the whole sample
Mm-hmm.
is 4. So 1 minus half. So we are left with 1 by 4 upon 1 minus half is half. So it is again half. So what is this half and this half equals to means what? We can write probability of B given A is equals to probability of B given A complement, which is equals to probability of B. Correct? See, B is first
Mm-hmm.
and it is equals to probability of B. Both are half. So means what? That A means condition. Condition, whether we put condition of A or condition of A complement, it is not affecting the probability of B. It remains the same. Therefore, we can say that A and B are independent events. You got that? Yes or no?
Mm-hmm. Yeah.
Clearly. So now come on, you can read this. We'll take this on board. So independent events A and B are independent event if knowing whether not one event has occurred. Means if one event has occurred and we are noting the probability of the other event to be occurred and it does not changes the probability. The event which was occurred earlier doesn't changes the probability of the event that has to be occurred, then it is known as independent event. Is it clear? Yes or no?
Yeah. Yeah, I
Yeah.
understand. Yeah.
Yeah. Moved on to the second desktop. Just a minute. See, it moved on to this desktop. Am I audible? Yes.
Mm-hmm. Yeah,
Okay.
yeah,
So
audible.
so that's the case in independent events here. So that's the formula. You need to verify the both. This is the case, then A is independent, and this is the case here. This first thing that comes. That's very easy just to remember. There are no shortcuts and no long cuts in here. That's very easy to be remembered there. Okay. So these are several examples of this. So we'll read this so that it's very clear. Let's contrast the coin toss scenario which out earlier Pierce your example with our earlier Pierce your example. In that case, the random process involved randomly selecting a student from a college statistics class. The event of interest toward A is male and B has a Pierce here. Are these two events
Mm-hmm.
independent? That's a good question. We'll take on to it this question onto a board and you will tell me. I'll do the calculations and all because it is very new introduction to you. So I'll do the calculation and you will tell me whether they are independent or not, A and B. Okay. So what we need to do, you know the task. If you want to see independence of two events, what we need to do for seeing the independence of event, for seeing the independence of event A and B, we need to test. We need to test what we need to test for A, what we need to test probability A given B must be equal to probability A given B complement will must be equal to probability of A. So we can say that A is
Mm-hmm.
independent and for what we need to test for B, B given A is probability of B given A complement should be equal to probability of B. Understood?
Yeah.
Yeah. So we need to calculate all this. So first I'll calculate probability A given B. So you know that how do I, it is very easy with the two-way table. So probability of B. What's the probability of B means I'll make it clear here what is A and what is B. So it will be very much clear. A is male, male and B has a pierced here, PE. Okay. So now probability of B. So it has a pierced here. Pierced here where I look for here, see here, here. So it is a total 103. And what is the intersection of A and B? means he has a peer share and he has a male. So it's 19. Yes or no? Are you getting that how to
Mm-hmm.
calculate? I'm doing just, if you want, I write the formula by the way.
Mm-hmm.
What general formula I have given you, not in the terms of probability, but in the terms of number of elements. So number of elements in B, peer share, it's 103, and intersection is always two-way table. You have to look for male and peer share, it's 19. So 19 upon 103. Okay. So now I'll go with, I'll put a comma here and probability A given B complement. A given B complement. So it will be number of elements in A intersection B complement upon number of elements in B complement. So what it will be, I'll do it
Mm-hmm.
below. B complement means not pierced here, not pierced here. So I'll look into not pierced here, it's 75, 75 upon A intersection B means not a pierced here and male, not a pierced here and male, it is 71. So it is 71 upon 75. So if we want to do a calculator calculation, if we are not getting it from the
I don't think
fraction, by
it's
the way,
independent. I think they're dependent on each other.
dependent, yes, dependent, yeah. It's 0.1844. I'll write the answer by the way for this 18.44%, and here it is 71 upon 75, 71 divided by 75, it's 94 point, it's around 94%. I'll write it, I don't remember the point. So therefore you know that probability of A given B complement is not equal to probability of A given B is not equals to, and you can find the probability of A as well. What is the probability of male? For if you want to find it, that's all, that also. What will probability of A be? So it will be number of elements in A. So male, how many are male? 90 upon it's 178, the total. Now we need to look to the total here in a sample space. So 90 upon 178, it's 90 divided by 178, 50.56,
Mm-hmm.
50.56,
Yeah.
yes, 50.56%. So you can see it's not equal to probability of A. So what you can tell is, come on, interpret me the result, that A is not independent, or you can write it as simple form, that means A is dependent. A is
Dependent on B.
dependent. Dependent on B. Is dependent on
Mm.
B. Got that?
Yeah.
And you can see it is a real life example. In India here, I don't know in of US there. Males generally don't peer their ears. Okay, pierce their ears. That's the case. Okay, so that's the case. So you can find whether B is independent or not. And in 99% of the cases, if A is dependent on B, then B is also dependent on A. B is also dependent on
Mm-hmm.
A. We'll do one calculation and just see for this example so that it is more clear. Probability of B given A. We'll find it. So it will be number of element in B intersection A upon number of element in A. So what is A? It is a male. He's a male. So male. I look into the table. How many are male? 90. So it is in the denominator it will come into be 90, and it will be 19. The total will be 19. We know. Okay. So we'll see with this one. But just we'll verify probability of B given A complement. So how many are female? How many are female? 88. 88. So that comes into the denominator 88. And what's B intersection A complement? B intersection A complement. B means pierce here, and A complement means female. So it's 84 upon. And you can generally look how much difference is there. See, there is the fraction has a difference of 4, and here it has a difference. So usually it will not be equal. Yes or no? It will not be equal. So
Mm-hmm.
B is also dependent. B is also dependent on A.
Yeah.
Got that, Zay? Yes or no?
Yeah. Mm-hmm.
Yeah. What is the iftari time there?
Huh?
What's the iftar time there? At what time you break your fast?
7-Eleven.
7:11. Oh, that's, and what's the suhoor time? Sehri time? At what time the sehri ends?
Mm,
Sehri ends
5:10.
5:10. Oh, that's a long fasting. Here also it's all about. It ends at 5. It was today. It's 5:08. It was today, and iftar is at 6:52. So near about
Mhm.
20 minutes or more in US and 20 minutes less in India. That's the case. Okay.
Mhm.
So then you see here, he has done all the calculation and he has saw that they are not independent. Got that? Yes or no?
Mhm. Yeah, I
Yeah. So
got it.
we will see this example tomorrow and complete our chapter. Okay, chapter. Then
Yeah,
there is a
okay.
general multiplication rule. So independence applies some general independence rule. I'll show you how it is, how we came there, how we came to this formula. This one,
Mhm.
this one. Probability of A given B. The formula was probability of A intersection B upon probability of B. But how do we came into this? When we are saying that when
Mhm.
A and B are independent, this is equal to directly this. Yes or no? These both are equal. How we came
Yeah.
on to this? So we'll see it inshallah tomorrow. So that's for today. You need to solve some example. Have you given the test? No, I think so.
Uh,
So
not yet.
so you can give it on weekend. I know you have a holiday from 6 to 14. From 6 to 14, what we'll do, we'll have two
Mhm.
class. Is it okay? We'll have two class, one in the morning and one in the evening. Yeah.
Yeah, that's fine.
Okay, that's fine. We'll take two classes because we are very left
Mhm.
with our problem solving statements also. We need to solve many of the problems from the previous chapter as well. So after completing this chapter, first task will be that we'll solve questions from chapter 3, 4 and 5. We'll take 4 to 5 classes in which we'll solve only the problems of based on chapter 3, chapter 4 and chapter 5. A lot of examples so that our concepts and all the things and you score well in your exam. Then after that, we'll start with our chapter 6. Is it clear? So that's all for today. Thank you very much. Salam alaikum. Take care and say salam to all your family members, including your mother, father, and Zoya. Okay. Salam alaikum.